Hi everyone, welcome to our coverage of Chapter 17 and a little bit of Chapter 18. So Chapter 17 is all about thinking about chance and probability, and it really focuses on introducing some terms and ideas that are going to be really important for us moving forward. And in this particular set of lecture videos, I wanted to not only focus on some of those ideas in Chapter 17, but also touch on a few things that are mentioned in the first part of Chapter 18, specifically some probability rules and this idea of what a probability model is. We'll have another set of videos all about Chapter 18 where we delve more into the idea of more complicated probability models. As we get started here, I hope you'll look through the cartoon here on the first slide. It's from Doonesbury, and it's related to some of what we'll talk about. So I hope you'll see the relationships and realize why it's a funny cartoon. So maybe go through the slides and then come back to this to see how it relates to the ideas we'll be talking about. As we get started here, I wanted to pose a question to you. And this question actually comes from a news article that was in USA Today a few years ago, and it was all about how individuals interpret weather forecasts. So every single day we hear something about the weather. All of you have heard a weather forecast at least once in your life. What does it mean if someone tells us there's a certain % chance that it will rain? So imagine that a weather forecaster tells you there's a 30% chance of rain on a given day. What exactly does that mean? So I want you to think about this a little bit. Look at the answer options here. What is your first instinct telling you? What do you think the answer would be? We'll come back to this in a little bit. Don't peek at the news article to see what the answer should be. But just think about, what do you think coming into this lecture? What do you think this means? Now, probability is in the news all the time. Every day or maybe not on a daily basis, but on a very regular basis, we'll hear something that relates to probability. And I just wanted to share with you something that I heard one day. I was driving to campus. I have a long drive to campus. I listened to news radio, and I heard this study. They were talking about how a long commute could be the last thing your marriage needs. And of course, I don't want to hear this. I have a long commute. I've had a long commute for a long time. I have over an hour commute each way to campus. So I was curious about this. And basically, according to at least one study, if one spouse commutes longer than 45 minutes, that couple is 40% more likely to get divorced. So we have a probability here, a chance that something's going to happen. And I was kind of relieved, though, to hear a little bit more about the study. So couples who have already spent 5 years or more commuting more than 45 minutes are only 1% more likely to get divorced than couples with short commutes. So I breathed a sigh of relief there, because I have been commuting a long ways, more than 5 years. But this is just one example of how probability is everywhere. We hear about stories like this all the time. The chances that something are going to happen. What's the probability that something is going to happen? Just again, in everyday life, probability is a big idea. So we make decisions on a daily basis based on the rules of chance. And so I'm going to be kind of moving around a little bit here to get out of your way when I can. But here are just a few quick examples. And this is just, again, these are just a handful of examples, not an exhaustive list. But is it worth it for me to undergo surgery or to take a particular medicine? What are the chances that this medication will lead to side effects or will help me overcome my illness or get past my pain? What car should I purchase? What are the chances that this car might break down or have certain mechanical difficulties? What college should I apply to? What are the chances of getting into a particular major or getting into my first choice of a college? What courses should I take? What's the chance that I'll get an A in a particular course? What's the chance that I might fail a course? Again, based on the weather forecast, what should I wear? If they say there's a certain % chance of rain or snow, or a certain % chance that the humidity index is going to be a certain level, that's going to have a bearing on decisions I make about what I'm going to wear, whether I bring an umbrella with me. whether I should leave early to avoid bad roads, whether I should leave later after the roads have been de-iced. Should I play the lottery or make a bet or employ a particular strategy in a game? So all of these things relate to probability. Probability is everywhere in everyday life. And many games are based on probability. So here are just a few quick examples. So I'm sharing all of this really just to motivate our study of probability. Probability is everywhere. It's a part of our everyday life. And we really want you to understand some of the ideas related to probability. Not just to get through chapters 17 and 18, but because this will be important moving forward in our other content. You're going to see these ideas of probability over and over again for the rest of the semester. So going back to our initial slide about the weather forecast. So I'm curious about what you thought about this. So what do you think it means if we say there's a 30% chance of rain? I'm hoping that you focused on this very last option here. So when we say there's a certain percent chance of rain, the weather forecasters are basing this on looking at lots of different possible patterns of what could happen given certain weather conditions. They're looking back in time to different days when different conditions were as they are now to see what kind of patterns are emerging over time. So in the long run, if it rained 30% of the time when conditions were a certain way, and if conditions are that way today, we're going to say that there's a 30% chance of rain. So it's based on looking at these long run patterns over time. What do we see over time? And that's something I want you to take away from chapter 17, that probability is all about what's going to happen over the long run. Not from just one trial to the next, but over the long run, over a long series of different trials. And hopefully that idea is going to make more sense as we look at some concrete examples. So one idea that comes out of chapter 17, or one term, is this idea of chance. So what are the chances something will happen? You're going to hear, again, this term quite often moving forward. So, and we equate chance with randomness. So chance or random behavior, as the slide shares, is unpredictable in the short run, but has a regular and predictable pattern in the long run. So what does that mean? What do we mean by the short run versus the long run? So again, if we talk about the long run, we want you to know what that means. And we'll come back to that shortly, but when we say random, what does that mean? So you've seen that term a lot in your life up until this point. People might say, or someone might say, oh, that's so random. It was a random occurrence. What does that mean? A lot of people might use this word in everyday life to mean one thing, but within statistics, the word random has a particular meaning. And we want you to understand what the meaning is within a statistical context. So when we say something is random in statistics, we mean that individual outcomes are uncertain or unpredictable, but there's a regular distribution of outcomes in a large number of repetitions. And again, just reading that definition, I might be a little bit vague, but we're going to see some examples of this. So individual outcomes are uncertain, but over time we see this regular pattern emerge if we look at lots and lots of different outcomes. So random is the kind of order that emerges only in the long run. So let's look at some examples of what I mean by that. So what are some examples of random events? The gender of a baby. From baby to baby, or outcome to outcome, we don't know exactly what's going to happen. We know there's a certain chance the baby could be a boy or it could be a girl. Over time, though, if we look at lots and lots of births, we'll see a certain percentage are male and a certain percentage are female. The outcome of a coin toss, from toss to toss, you don't know what's going to happen. So each individual outcome, each toss is unpredictable. You don't know exactly what's going to happen, but over time you're going to see a certain percentage of heads and a certain percentage of tails. Similarly, looking at rolling a die, We don't know each time what's going to happen. Over time, though, we'll see a certain percentage of 1s or 2s or 3s, etc. Spinning a roulette wheel, the outcome of a random sample or a randomized experiment. So that's an idea we hope that you're already thinking about based on content we talked about earlier in the semester. We know from sample to sample there's going to be variability. I take a random sample. I don't know exactly what I'm going to get. I don't know who's going to be in my sample. I don't know what the outcome's going to be. If you then go and take your own random sample from the same population, chances are you're going to have a different sample. You're going to have a different outcome. Someone else will take a random sample. They'll have another outcome. But if we look at lots and lots of random samples, we'll see some patterns that emerge over time. And that's actually something we're going to talk about when we get more into the latter part of chapter 18. So when we talk about this idea of probability, it's an outcome of a random phenomenon. So probability is a way of essentially giving a number to a random outcome. So it's the outcome of a random phenomenon. It's a number between 0 and 1 that describes the proportion of times the outcome would occur in a very long series of repetitions. So this idea of randomness and probability go hand in hand. If an outcome never occurs, it would have a probability of 0. If it always occurs, it would have a probability of 1. So the probability cannot be greater than 1, it cannot be less than 0. A lot of times it's somewhere in between. So I think I'll go through maybe 1 or 2 more slides and then we'll wrap up for this first part of chapter 17. But I wanted to talk about a coin toss. Coin tossing is something that I think everybody has some experience with. So it's an example that I hope everybody can clearly understand and think about and relate to. So each time you flip a coin, there's half a chance or 50% of a chance or a probability of 0.5 of getting heads and half a chance of getting tails. So notice here that I can write probabilities in different ways. As a fraction, I can talk about things in terms of percentages. I can talk about things in terms of actual probabilities or numbers between 0 and 1. Here's my question to you. So how exactly do we know that there's a 50% chance of obtaining heads and a 50% chance of obtaining tails? So we toss a coin, we say there's a 50% chance, but how do we know that? Remember, from outcome to outcome, we don't know what's going to happen. We don't know for certain what's going to happen. Some of you might be saying, well, there's just 2 possible outcomes, so there must be a 50% chance of each. You know, if the coin is weighted in a certain way, we'd expect that one side wouldn't occur more often than the other. But the reason we can say there's a 50% chance is not because there are 2 outcomes, but it's because we know what would happen over time if we toss this coin many, many times. We'd see in the long run, we have 50% heads and 50% tails. So it's not just that there are 2 options, but it's what we would imagine would happen, what we know would happen if we toss that coin over and over again in the long run. And luckily, statisticians have done that. They've tossed coins many times. In your textbook, there's actually a graph that shows the outcomes of many different coin tosses. So we know what happens in the long run. Sometimes we don't know, but if we have a good understanding of probability, we can make some good conjectures of what will happen in the long run. So I'm actually going to stop here and then we'll pick this up again in our next video.